Hello and welcome to our new video where we will learn how Bugatti manufactures the fastest car in the world. The complete process will be explained using pictures of different things, from the machines and the engine to the car frame, each and everything. We'll explain the complete process in this video, so please don't miss any of the details because it can really affect your understanding of the final vehicle if any information is missed out, okay? Basically, we are taking a step-by-step tour through the meticulous, hand-assembled manufacturing process of the Bugatti Chiron.
So how do you build a car that defies physics? Well, let's dive right into it. It all started with this completely impossible brief. The design engineers were tasked with something the rest of the automotive industry kind of laughed at, cramming 1,500 horsepower into a street-legal vehicle. Critics said, no way, it literally can't be done. But the true challenge wasn't just generating that unbelievable power. It was making sure the car didn't actually take off like a literal airplane when it hit maximum acceleration. You see, when you're building a motorized superlative like this, you have to ensure there's enough weight and downforce on the front end so the thing stays glued to the asphalt.
And honestly, this number perfectly illustrates the extreme stakes we're talking about. 420 kilometers per hour. That is the governed top speed of this absolute projectile. At these speeds, the Chiron doesn't just drive on the road, it's genuinely scratching at the boundaries of physics. We're dealing with an ultra-powerful work of art that can launch from 0 to 100 kilometers an hour in a mind-bending 2.4 seconds. To put that into perspective, we're looking at numbers and performance metrics that feel completely unreal for a car that you could, theoretically, drive to the grocery store or the opera.
To understand exactly how they pull this off, here is our roadmap for today. We're going to cover 1. The impossible hypercar brief. 2. Building the W16 engine. 3. The carbon monocoque chassis. 4. The marriage of two halves. 5. Aerodynamics and final assembly. And finally, 6. Extreme testing and delivery.
Okay, part 1, the impossible hypercar brief. Our journey actually kicks off in Molsheim, France. Now this isn't your typical grimy, noisy car factory. Bugatti calls it the Dream Factory, or the Atelier. It sits right on the site of the former Bugatti family estate. And get this, the building is shaped entirely like the company's oval logo. Inside, you won't find a classic automated production line. Instead, just 20 elite employees work at 12 pristine, hospital-like stations. They assemble up to 16 vehicles at a time, strictly by hand. It feels way more like a high-stakes Formula One racing stable than a standard car plant.
To solve that massive weight problem and survive the colossal forces it generates, the car needs to maintain a very healthy body mass index. The engineers pulled this off by utilizing the absolute finest, lightest exotic materials available. We're talking carbon fiber, titanium, magnesium, and specialized aluminum. These are materials you'd normally only ever see in aerospace engineering or F1 cars. Every single piece is designed to be as compact and light as humanly possible without sacrificing even a millimeter of structural integrity.
Moving on to part 2, building the W16 engine. For this, we have to travel over to the engine plant in Salzgitter, Germany. This is where a highly specialized team constructs the absolute heart of the beast, the 8-liter, 16-cylinder engine of the Chiron. Whoever works in this specific department belongs to the absolute elite of engine mechanics. In fact, there are only about 8 technicians worldwide who are even permitted to build this specific powerhouse.
Just look at the sheer scale of this engineering feat. The final dimensions of the Chiron's W16 engine are roughly 4 times the size of a standard passenger car engine. It weighs a massive 640 kilograms and is constructed from around 3,700 individual hand-assembled parts. The engineers essentially take 2 V8 engines and merge them together to create an artificial W shape. It takes 2 master technicians a full week just to build one of these 1,500 horsepower quad-turbo units. It's just wild.
And to wring every single ounce of power out of that massive engine, Bugatti utilizes sequential turbocharging. This solves a huge headache in high-performance cars, which is turbo lag. Instead of all 4 turbochargers spooling up at once and causing a delay in power, they're staggered. Turbos 1 and 2 engage instantly the second you hit the gas. Then, once the engine hits 2,800 RPM, turbos 3 and 4 violently kick in. This staged compression ensures a constant, brutal, linear delivery of power that just firmly pins you back into your seat.
All right, part 3, the carbon monocoque chassis. While the engine is being tortured on the test benches in Germany, let's jump back to Molsheim. A very expensive delivery arrives at the factory doors, the carbon monocoque. This is a hollow driver cockpit made entirely of carbon fiber reinforced plastic. Despite having to safely house 2 passengers at over 400 kilometers an hour, this bare structural framework weighs an astonishingly light 150 kilograms. It gets lifted onto a specialized assembly platform, ready to become the foundation of the rolling chassis. But before that massive engine can be attached, technicians have to install the car's incredibly complex central nervous system. Inside that tight carbon cockpit, they meticulously weave 2.5 kilometers of wiring harness. This intricate web of cables connects the vehicle's 20 distinct control units, and true to the whole hypercar brief, they don't just use standard fasteners. The mechanics secure these electrical wires to the monocoque using ultra-lightweight titanium screws, because, as you know, every single gram matters when you're defying physics. Which brings us to part 4, the marriage of two halves. This is really the narrative climax of our factory tour, a delicate ceremony the mechanics simply refer to as the marriage. Because the Chiron doesn't have a traditional unibody, the car is literally made of two distinct halves. The front carbon monocoque has to be perfectly joined with the 750-kilogram rear engine frame. They move the assembly platforms to the exact same height and so carefully maneuver the two massive sections together.
As one Bugatti technician put it, we start with nothing and build the vehicle. You have to work very precisely. You can't afford to make mistakes. The precision required here is literally surgical. If these two gigantic sections, one made of carbon and one of metal housing a $300,000 engine, are misaligned by even a fraction of a millimeter, the entire thing has to be taken apart and adjusted. It is an incredibly high-stress, zero-margin-for-error environment.
But what's truly fascinating here is the sheer trust placed in minimal hardware. These two halves, which together house 1,500 horsepower and will endure lateral forces of up to 2G, are joined firmly together by just 14 titanium bolts. Literally, 14. But this isn't some crazy cost-saving measure. It's a highly calculated safety feature. The vehicle is specifically designed so that in the event of a catastrophic high-speed accident, those bolts will shear right off, allowing the heavy, potentially flammable rear engine section to safely tear away from the driver's carbon safety cell.
Okay, part 5, aerodynamics and final assembly. With the rolling chassis complete, the focus shifts to keeping it from flying away. A car weighing 2 metric tons requires complex, adaptive aerodynamics to keep it glued to the asphalt. The Chiron's entire exterior paneling consists of 55 distinct parts that act as an active and passive aerodynamic system. As the car speeds up, it channels the impacting air pressure through the front curtains and past the body to physically press the Chiron down.
To see exactly what those aerodynamics and that massive power can achieve together, just look at this 2017 world record set by racing driver Juan Pablo Montoya. He accelerated the Chiron from a standstill to 400 kilometers an hour and then hit the brakes to come to a complete stop. The total time? 41.96 seconds. He reached 400 in just 33 seconds. When he hit the brakes, the adaptive rear wing hydraulically tilted to a 49-degree angle in 0.8 seconds, acting as an extreme air brake. 850 kilograms of force pushed down on the rear wing, bringing this absolute missile to a dead stop in less than 9 seconds.
And to stop 2 tons of mass moving at 400 kilometers an hour, you generate friction that honestly defies belief. Brake temperatures on the Chiron soar to 1,100 degrees Celsius. That is literally as hot as glowing lava. Standard brakes would just melt into slag. Bugatti utilizes massive carbon ceramic brake discs, but the real star of the show is the brake caliper. Because it has to endure such immense thermal and physical loads while staying perfectly rigid, Bugatti utilizes the world's largest 3D-printed titanium part. It's a masterpiece of technical development where material is placed only exactly where the load path requires it.
Finally, part 6, extreme testing and delivery. So, the car is built. But it is far from ready for the customer. Now begins a rigorous, punishing gauntlet that every single finished Chiron must run. Before delivery, the car goes through a 350-kilometer real-world test drive. To protect the multi-million-dollar paint job, it takes a worker half a day just to cover every single millimeter of the exterior in a protective film. Then, a highly trained test driver takes it through villages, up into the mountains, and finally to a rented airfield to safely verify its immense power.
But before it even hits the open road, it has to pass the dynamometer. When Bugatti created a 1,500 horsepower car, they quickly realized a massive issue. You couldn't find a test bench anywhere in the world that could cope with this much power without snapping. So Bugatti had to internally invent and custom build the world's most powerful rolling test bench. The car is strapped down, and an employee runs 342 intense diagnostic tests, simulating a 60-kilometer drive at speeds up to 200 kilometers an hour, all completely indoors.
All of this relentless testing, this obsessive attention to detail, and this pursuit of extreme materials ties back to the very roots of the company. The founder, Ettore Bugatti, was a Milan-born visionary who achieved worldwide fame way back in the 1920s. He had a philosophy that still governs the Molsheim atelier today. Perfection is never achieved, but the designers and mechanics of the Chiron attempt to get as close to it as humanly possible, constantly pushing the boundaries of unbridled power, technical beauty, and flawless elegance.
Which leaves us with a really fascinating question. When a company routinely shatters the 400 and even 490 km/h barrier, what engineering boundary will be broken next? Bugatti has proven they don't just build cars. They engineer motorized superlatives that force us to rethink the very limits of physics and human ingenuity. Thank you so much for joining us on this factory tour. If you enjoyed this, please like, comment, and subscribe to Talk Theory Explains to never miss a deep dive.